The next network modeling problem is called assignment problem or assignment models. And assignment models is a special case of transportation problem. Just imagine the same format except that for each of the origins the capacity is exactly 1, and for each of the destinations the demand is exactly 1. So that means you're assigning one plant to one destination, okay, whichever destination. Okay, the assignment may have a cost involved, in which case you want to do the assignment at the minimum cost, or the assignments may generate profit, in which case you want to make the assignments in such a way that the total profit is maximized. So each flow then in the transportation is going to be either 0 or 1. So 0 means the assignment is not made, 1 means the assignment is made. So let's look at the network representation of this problem, okay, which is like this. So in this problem we have machines, we have 5 different machines and 4 different jobs, and we want to assign the machines to jobs. So the most basic assignment problem, all the capacities here will be equal to 1 and all the demands will be equal to 1. But this one is a slightly modified assignment problem because the machine 2 and machine 4 can handle 2 jobs at the same time. So here are the arcs, and the arcs for 2, 3 and 4 are not shown because the network will become really cluttered. You won't be able to make any sense out of it, and that's why those are not shown, but they are there. You just imagine that they are there. And the numbers here are the cost of assigning the job to the machine. We want to set this up as an Excel model and solve it. So let's look at the Excel file. Okay, here are the numbers given. So let's do some formatting. Okay, so these are the assignment costs. These are input values given. Okay. These are actually times. If you assign job 1 to machine 1, how long will it take? So 14 hours and 2 hours and 5 hours and so on. And the machine capacity is given here, and these are the assignments that we want to make. So it will be 0 or 1. Okay, and let's give a name here. Assignment plan. Okay, now if you sum this way, okay, so that will be how many jobs will get assigned to that given machine. Okay, and you cannot assign more than what the machine can handle. So that's our capacity constraint. So let's copy that down. Okay, let's put a line through here. Now if you sum this way, so to how many machines a given job gets assigned. Of course you need that to be equal to 1, because you can assign a job to more than one machine at the same time. So this value will be 1. So copy that. Now, okay, and the objective to minimize is the sum product of the times with the assignments made. So if the assignment is made, it will be 1 gets multiplied by the time, it will get picked up. If the assignment is not made, it will be 0. So 0 times the time will be 0, it won't get picked up. So only the times needed for the assignments made will get selected in the sum product, and it will be summed. And that's what we want to minimize. So let's color code that, and we'll give a name here. Okay, jobs on machine, machine capacity, name that, machines on job and required, okay, name that. So we'll run solver, that to be minimized, changing cells, and add that is less than or equal to capacity, and that is equal to required. Or you can just simply type 1 here as well, that will also work. And the options, you set those and solve. Solver has found a solution, and here is the assignment of jobs to the different machines, and this assignment will give you a total time required for production of 14.